Alright, that's it. A rescue boat whose maximum speed is 24 kilometers an hour is 18 kilometers southwest of a fixed point P. Okay, so I'm going to draw that straight away. So we're going to have P here, and southwest is left and down at 45 degrees, and we're going to put that as the rescue boat B. Alright, and we are 18 kilometers in this here, right? Now, there's a constant current of 4 kilometers an hour and flowing uniformly in the direction of south 30 degrees east. It basically means the boat can't just aim directly at P. It has to account for a current that's either that will be flowing it away from where it wants to go. So we're gonna break up the current into its components now. So the current is flowing in the direction. So please check for in versus from. So it's actually going southeast. So that's handy to know. And then south 30 degrees east. So please double check that as well. You go south first, directly south, and then you just do 30 degrees east. So that's 30, which will make this part 60. Read it again. We're good. And it's 4 kilometers an hour, isn't it? So I'm going to do 4 cos 60 and 4 sine 60. 4 sine 60 I think is 2 root 3, and 4 cos 60 is simply 2. So the velocity of the water, is that what I'm looking for? Velocity of the water is 2I minus 2 root 3 J. You all cool with that, guys? Now nextly, we're going to go for velocity of right, that's done there. Okay. Find the time to nearest minute to reach P, and you want to get there as quickly as possible. Okay, so I'm going to do my magnitude direction trick. Everybody knows my magnitude direction trick? Magder. Alright, so velocity of the boat in water is the velocity of the boat minus the velocity of the water. The actual velocity of the boat is the velocity of the boat in still water plus the velocity of the water. Alright, very similar to crossing the river, isn't it? Alright, and what we're going to say here is there is usually 6 pieces of information. You can work with 3 of them, but you usually need 4. Okay, and we're going to see how many pieces of information we have here. Okay, so mag and direction. Okay, how fast can the boat go in still water without any water assist? 24, sorry. You go 24. Okay, we also have the velocity of the water is 4. The direction of the water, I'm going to go for east 60 degrees south. Okay, it's the same thing, isn't it? It's the same thing as south 30 degrees east. They're the same direction. One piece of information now. What's the last piece of information? Anybody know? I believe we know what direction the boat has to go in, don't we? What direction does the boat actually have to go in to make this happen? The boat's here and has to go up to P. So what direction is that? That's northeast. Exactly northeast. So 45 degrees. So this is exactly northeast at 45 degrees, okay? Now we're going to use trigonometry to answer this. So start off with pick your 2 that you're going to start off at the same place. I'm going to choose phi W because I have all its information, and then I'm going to use phi B. We said northeast for that, didn't we? Right, so I'm going to use phi W and phi B as the common starting point. So let's start off with phi W. Go across at a degree of east 60 degrees south. So east 60 degrees south. Don't know how long to make that, but I know it's 4 and I know it's phi W. Okay. Then go with phi B. So what we reckon with phi B? 45 degrees northeast. Okay. Now when we really think about it, think about your original question. Your river's forcing you down this way, isn't it? So realistically, you're going to have to aim at it at a steeper angle than what you're looking for, aren't you? So you're always going to have to aim at a steeper angle, and you're going to get pushed downwards, aren't you? So I know that if this angle here is steeper than 45 degrees, so there's the 45 degrees there, and there's the steeper direction I'm actually aiming in. So this is the velocity of the boat in water, and this is what we're actually doing, velocity of the boat. And what do we say velocity of the boat in water is? 24. Okay. What direction have I not put in yet? I haven't put in. What angle is this? It's the velocity of it's the direction of the water, which is 60 degrees, okay? So now I have 105 degrees on that angle there. Okay, so that's going to be 105 degrees. Now, reread your question and figure out which piece of information you want to get first. The time. If I'm looking for the time, it's 18 kilometers divided by phi B. So my whole goal is to find out phi B. Phi B is the target. And then 18 divided by phi B will actually answer my question. Okay? So, yeah, I'm going to do a sine rule, figure out angle X, and then from there I can figure out phi B. So we're going to do 4 over sine X equals 24 over sine 105, and then sine X equals 4 sine 105 divided by 24. If you sine inverse that for me, we can find out what the angle X is.
9.26 degrees.
9.26 degrees. Okay. Do I need to take into account the 180 take away that angle? Do I need to take into account the second quadrant? Well, is there only one answer or two answers for this question? There's one answer, and you also have an obtuse angle is already present. So the other angle would send it over 180 degrees, so it's not relevant here. Okay, so you wouldn't do 180 take away 9.26. The question says there's only one answer, and if you were to use 180 minus 9.26, it would send the answer above. That'd be like 171 degrees. And with that and the 105 degrees, it would send it way over the top, so you don't need to worry about that. Is that alright with you guys? Now, so we found out that's 9.26, so what does that make the other side? .26, so add it to 105 and take it away from 180.
65.74.
What is it? 65 points?
74.
Then we'll just go for another sine rule. Phi B over sine 65.74 equals 24 over sine 105. And then cross multiply to get phi B. So 24 sine 65.75 all over sine 105. And what you get? 22.65? You all good with that? Is it kilometers per hour or?
Yeah.
Alright. Do yourself a favour when you're obviously studying. You might want to actually just check as you go along. I'm happy with that 22.65 there. Okay? So, pretty happy with that. Time to move on. Now, a yacht is in distress near P and it sends a signal to the rescue boat. When the rescue boat arrives at P, the yacht is 6 kilometers north of P and is drifting with the current. The rescue boat sets out on P to reach the yacht as quickly as possible. Find the time taken for the rescue boats to reach the yachts. I have to reset the full question, do I? Do a hard reset and then just write down the scenario again. So, yeah, I'll reset this information here. So a hard reset. Okay, I think stuff I have underneath will actually come in useful. But here we go. The yacht is in stress. A yacht is in stress near P and sends a signal to the rescue boat. When the rescue boat arrives at P, so you're currently at P and the yacht is 6 kilometers north. Now, we're at point P, but we're still technically the boat. So we're still B. We're B at point P, and the yacht is Y. And it sends a signal to the rescue boat. When the rescue boat arrives at P, the yacht is 6 kilometers north of P and is drifting with the current. The rescue boat sets out at P to reach the yacht as quickly as possible. Okay, no worries. There's an easy way to do this as well. Alright. So what direction is the yacht going in again? It's going in the direction of the current. And I think just give me a sec. That's the current there, isn't it? The current is 2I. The current is 2I minus 2 root 3 J. So that's actually the speed of that's the speed of the yacht, isn't it? So that's where the yacht's going. Okay. So we have next is yacht, boat. Now, what's the deal with the boat? What's the only thing it needs to match to make this collision occur? The yacht goes 2 across and 2 root 3 down. What's the only component the boat has to match to ensure that this is a collision? The boat just needs to go 2 across and whatever the hell it has going upwards. And next thing is, what's the speed of the boat again? 24. But yeah, I know. Have to take in consideration the actual current. That's the issue. We got to take into consideration the current itself. All right. So that's not so bad because the boat's actually in the current as well. So it's also affected by the current. So it's not what you're doing there. So here's what's going to happen. All right. What happens if the boat aims all 24 straight up? What does the current automatically do to it? It automatically moves it 2 to the right and subtracts 2 root 3 from its upwards velocity. Does that make sense? So it's actually going to be 24 minus, you're going to be going 24 minus 2 root 3 upwards, aren't you? But what's the other problem? The yacht itself is actually coming 2 root 3 downwards, isn't it? So what's the effect of that then? The 2 root 3's are going to cancel because when you think about it, the actual velocity of the boat is 24 minus 2 root 3 upwards. The velocity of the yacht is actually going 2 root 3 downwards. So you're actually going to, the 2 root 3's are, That's actually a -2 root 3. Why is it a -2 root 3? It's going downwards. So it's going to be a double negative in effect there. So it's going to be 24 minus 2 root 3 plus 2 root 3. Just turns it into a 24. And then it's going to be 6 divided by 24. Quarter of an hour. 15 minutes. And that's the correct answer, is it? I'll check. 15 minutes. As you can see, the marking scheme doesn't give you much information there, does it? Just throws the answer out of nowhere with no explanation. So marking scheme can be a guide, but often it's lacking detail, isn't it? Alright. So there we go.